Alright guys, here are the answers to the problems we did in class. The first problem asked you to factor 3x squared plus 8g plus 4. So again, I noticed right away that this is in ax squared plus bx plus c form, but the number in front of the x squared, that term, that coefficient is greater than 1. So I'm going to have to first multiply the first and last terms, the a and the c, and get 12. And I'm looking for the two things that multiply to 12 that add to 8, which would be positive 6, positive 2. So now I have to rewrite the trinomial as a 4-term polynomial. Notice that I took my 6 and 2 and put them as my two middle terms in my 4-term polynomial. Then what I'm going to do is I'm going to group the first and the last terms and take out the greatest common factor. Here they share a 3 and a g. I'm going to divide each of them by 3g, and I'm left with g plus 2. Here the greatest common factor is 2, and I'm left with g plus 2. So now that I grouped them and they have the same thing written inside the parentheses, my two factors are g plus 2 times 3g plus 2. And there I'm done. Those are the factors of the original problem. The next problem does the same thing. It asks you to factor 9r squared plus 15r plus 6. Same kind of problem. I have a ax squared plus bx plus c, but remember, the first thing I always want to look for is, can you factor out a common factor? Well, each of these has a common factor of 3. You could divide 3, but you don't want to divide 3 because it doesn't equal 0. If it equaled 0, you could just divide everything by 3. But now I'm going to have to just factor it out. So I'm going to factor out a 3, and I'm left with 3r squared plus 5r plus 2. Now this is going to make it a lot easier to do my next kind of factoring, because instead of multiplying 9 times 6, I'm going to be multiplying just 3 times 2. Because I have a trinomial in there, and the way I factor trinomials that has a coefficient greater than 1 is I'm going to multiply 3 and 2. I'm looking for the two things that multiply to 6 but add to the middle term 5. So that would be 3 and 2. And again, I'm going to do exactly what I did in the last problem. I'm going to keep my 3 out on the side. I won't forget about it. And I have 3r squared plus 3r plus 2r plus 2. And then I'm going to go through that grouping process again. Oops. 3r they share, and I'm left with r plus 1. And here they share a 2, which I'm left with r plus 1. And I'm going to factor it into 3r plus 2, the outside terms right here. And then inside the parentheses would be r plus 1. It's the same. So I only have to write it once. Then I'm just going to make sure I bring down my 3, because you're actually going to be multiplying 3 things, 1, 2, and 3 factors in order to get back to the original problem. And this is it in factored form. Next problem says factor 9x squared minus 100. And the first thing I notice is that I have a difference of 2 squares. So I'm going to make sure I write it as, what am I squaring? And you could only do this with subtraction. What am I squaring to get to that? And since it's the difference of 2 squares, I can write it as, I'm sorry, this was x right here, 3x plus 10 times 3x minus 10. And there I'm done. That's the factored form. That's the difference of 2 squares. Number 4, the amount of mice has been cut in half each year. Since I'm cutting in half each year, I know that it's going to be an exponential function. So first of all, let me write an equation. In the beginning, there were 1,200 mice. Well, that's the y-intercept. That's when x was 0, the number of years were 0. So I'm going to put a 1,200, and then the growth factor is 1/2. You could have also put in 0.5 to the x power, where x is the number of years, y is the number of mice. So when it says, how many mice will there be in 2017? That'd be 10 years since 2007. So I'm going to go ahead and plug in a 10 right there. And in my calculator, I'm just going to use that. I'm going to go ahead and do, whatever this equals is going to be your answer. Now for the next problem, it says, when will there be under 10 mice? Well, in this case, you could keep plugging in numbers in here till you get under 10 mice, but the best thing that you can do is with your graphing calculator, if you go ahead and graph this original equation and look under your table on your calculator, you can just look for when y is going to be less than 10, and whatever the x is, that's your answer. Last problem, it's going to be alright, so what we basically found, by the way, was that in that last answer there was 1.17 or 1 in 1700ths mice, or about 1. And the second answer would be after 6 years you find on your table, or at the 7th year, the number of mice is under 10. Last problem is solve this particular problem. And you notice that I actually made a mistake. So if you were doing this at home, this is actually a good test. Don't forget how to solve. Just because we're doing quadratic, you're still going to be able to solve regular equations. So here you would have to combine everything on the same side. I meant to make this a quadratic, but the way it is, you get negative 10x, which equals 14. Now, if we have to solve, all that means is you want to know what x is, so I'm going to divide both sides by negative 10. And you're left with x equals negative 1 and 4/10. Just in general, though, remember that had I made this a quadratic, it doesn't matter which one I made a quadratic, what you would have had to have done is move the 14 over, and you would have got this equation. And because it's an equation, I would probably multiply everything by negative 1, which would change everything to the opposite. And that way, now I have ax squared plus bx plus c. And at this point, you can either factor, you could use the quadratic formula, or you can graph in order to find out what x is.